Good afternoon, everybody. I'd like to thank you for the opportunity of taking you through a presentation regarding maintenance management, asset control, etc. Or as we'd like to look at it, how to reduce production downtime, increase your capacity, reduce your costs. And would you rather fix it when it breaks or stop it breaking in the first place? Now, the agenda for today is a bit of an overview on maintenance management, some of the thought processes, some of the procedures, a bit of a product demonstration, followed by a short company overview on Epicor itself, and an opportunity for questions. If you can log your questions with the presenter, then that's perfectly fine. Now, in the beginning of the Industrial Revolution, which essentially was spawned from a level of mechanization in the agricultural sector, you had very simple technologies, especially relative to today. Large pieces of quite heavy, often cast equipment put together with some very substantial fasteners, fixtures, etc., because the materials weren't available to be stressed out too much, that they were almost power sources for people to then utilize and move forward, so slow punches and presses and that sort of thing. So we started off with some relatively simple technology. We involved a lot more manpower in the context of manufacturing. Maintenance was then simple. If you remember, those of us who are old enough, that you could once upon a time lift the bonnet of your car and understand where everything was fitting in the motor and all the associated pieces. Now I lift the bonnet and I despair because there's only a few things that I'm allowed to touch, and the rest of it is no untrained user serviceable parts. Maintenance was quite often more reactive and unplanned, again because we didn't quite understand the cost impacts and the mean time between failures and a number of those elements. So we're in an environment where manufacturing was in its early days. Equipment was fairly unsophisticated. We didn't quite have a grasp on maintenance management, and planning was considerably more reactive. Now, as time passes and innovation comes through, increasing rates of knots, the impact of productivity and the question of quality moves a lot more from the human being and into the machine environment. The advent of higher fasten rate machines, robotics, CNC machines, turret punches, all those sorts of things are now pushing it to de-skill the person in a lot of ways and empower the machine. So if that's the case, the importance of maintenance of those machines, the control of tolerances and behaviours of those machines, the uptime and availability of those machines is considerably increased. Your production capabilities are now not so much throw more people at it, but keep the machines running faster, better, and quicker. Now, it's not good enough these days to just repair equipment when it breaks, because I don't want to have to go through and repair equipment that's broken. I'd rather have it running at a higher capacity consistently. Now, we need to keep it running at a high capacity. Now, a higher capacity obviously means conversations around OEE and overall equipment effectiveness. Just because a machine runs fast and produces a lot of components doesn't matter quite so much if those components are outside of tolerance, because the machine is not running within tolerance. Producing quality parts at the lowest total cost is the driver. So maintenance is not just about does the machine run, but does the machine run in such a manner that it controls the quality and provides good quality throughput. People are becoming increasingly aware, and there are a number of people in this audience that I'm sure will feel the impacts of this all the time. The cost of poor quality. If I make it and it's wrong, I can't sell it, but I've done all the work. Cost of lost production. I've got machines sitting idle because they're broken or because they've drifted out of tolerance. We're now seeing the aging of machinery and the fact that they need more care and attention to keep them running. The sad element of a cost of missed deliveries because of any of the above. You put all that effort into winning business, all that effort into being the best supplier, and then your machinery lets you down. Then you layer in complications over things like spare parts availability, especially for older machines. Longer lead times for spare parts. Not everything is available straight away, but then you've got to compare that and balance that off to things like spare part inventory optimization. How much inventory do I keep in spare parts versus the long lead time? There's always a constant push for lower raw materials, lower component inventories, but spare part inventories are just as much of a drain on cash flow as any sort of materials. So it's always a balance point. Now, enterprises are always interested in lowering their maintenance costs. They'd obviously rather spend all their money making product and not spend anything on maintenance, because maintenance is seen as a cost, whereas production is seen as a value. But the reality that we work in is that maintenance that isn't carried out will result in machine failures, product failures, disruption to the flow of the facility, disruption to the supply chain to your customers, disruption to your market, brand damage, etc., etc. So maintenance which isn't carried out will cost you even more money than the maintenance that you do carry out. It's just a matter of, do you want to play Russian roulette with your factory? To some of us, we're absolutely aware of this. Other people don't necessarily consider all the hidden impacts. Capital costs. Why is that a cost of poor maintenance planning? Well, if I'm always running into a situation where I've got 5 punches and one of them's always broken, then I provision for a 6th and I invest more in capital. So that's my increased investment for the same rate of return. Or if I have 6 machines and if I did some appropriate maintenance outside of normal hours or during quiet times during production cycles or sales cycles, then I only need 5, then I've already invested more in equipment than I should. A safe working environment, a machine that doesn't run right, has the potential for being unsafe, and a lot of us work in environments where, quite rightly, occupational health and safety is a paramount consideration, even if it's just the machine running in a noisy manner and potentially hearing loss, etc. Lost market share because I failed to deliver on time, because I've got quality losses, I've got production losses, I'm slowing down on capacity. The world's energy market is getting tighter and tighter, and there's more of a focus on cost of energy and impacts of that. So if the machine is running out of sorts, it's going to draw more energy. The challenges we face with our production equipment is that capacity quite often diminishes as the machines deteriorate. as in they just run slower. Maintenance does impact production time. Now, we'll talk a little bit later about the concept of doing maintenance online and or offline. But normally a lot of maintenance is carried on offline, so the machine is unavailable for production. Whether we acknowledge it or not, production schedules are quite often impacted by this. And we have to balance out that cost of maintenance and the lost production. So if we look at, is it more desirable to have a rapid response to unplanned creative maintenance, or is it more desirable to have a controlled level of planned maintenance? Well, if you think about it, unplanned maintenance is a result of a breakdown, some sort of emergency repair. It's always urgent. It controls you, not you control it. So if you're running in a multi-shift environment, you can almost be guaranteed that Murphy will come to the fore and that the breakdown will occur somewhere around midnight or 2 a.m. and essentially the maintenance team isn't available to be on site all the time, so that machine is down until you get the machine fixed at 7 or 8 o'clock in the morning. And if you do have to call someone in, it's at penalty rates. It's substantially more cost, more inconvenience, more can go wrong. But if you were to do it as planned maintenance, it can be prepared for properly. I can make sure that I have all those spare parts that I believe I'm going to need. All the tools, jigs, fixtures, the appropriate resources and everything else available at a time that's going to least interfere with my production environment. The belief is that maintenance and production operate on the same equipment in the same environment, just at different times. So planning your production and planning your maintenance are equally important. You need to be able to be in control of your equipment. So how do we get unplanned repairs jobs planned? Well, we know we want to, but how do we get them across? How do we say, right, when will we maintain these? So one of the things we can look at is information from suppliers of equipment to their recommended maintenance protocols, build those protocols into the equipment, then monitor the performance of those equipments and the frequency of breakdown and, if you like, the mean time between failures. So we use reporting environments against production and production efficiencies, uptime of machines, to then validate that the machine manufacturers themselves are providing us with what is an optimum set of recommended surface intervals. The other way of doing it is to look at condition monitoring. So if you're running high-speed machines that have a temperature profile or a speed profile, you can look at the rate of production, you can look at the temperature of bearings, etc., the energy draw of those machines, and extrapolate when you're going to move outside of a desirable set of parameters and predict when maintenance should be carried out to then bring those pieces of equipment back in. So planning maintenance really can be quite simple. It can be the machine manufacturer, what they believe the service intervals should be, backed up by your own understanding and monitoring of those machines to evolve that through to a more precise level of service interval, or picking up various machine conditions and having that information then monitor drift, performance drift of various parameters, and extrapolate that through to when it's considered that maintenance is going to be required, not because the machine is broken down, but because it's continuing to drift, say, on a temperature profile or an energy draw. As soon as we do that, we can invoke those planned maintenance at a time that suits the entire operation in a planned manner that's executed in a shorter time frame. And then you get lower total cost of maintenance with less production downtime and less impact on the supply chain and your ability to meet customers' demands. Now, proper planning is all about doing it at just the right time. Not too early, not too late, not at a bad time of day. Getting it done in the right way. That means work instructions, whether they be documents, whether they be attachments, whether they be videos, whether they be third-party people. And then that comes into by the right professional. Do I have my maintenance subcontracted to the machine manufacturer? Or do I have a skills and capability matrix against my maintenance team so that I know that when I'm creating the schedule that the system is actually allocating the right professional to the right maintenance activity? With the spare parts, and it's the right spare parts, make sure that there is actually a, if you like, for want of a better expression, a bill of material for the capital equipment. Somewhere within the environment that you can pre-record that this is the bearing that gets used in that CNC machine. So I'm not checking through manuals and that sort of thing. If I have to do that, but at least be able to then nominate exactly what that is and buy that in. And do that while maintaining a balance of priorities. If I'm doing routine maintenance and I have the opportunity to let it slip a day or two, but I've got some high value, highly sensitive production going through, the system should understand that and allow you to move those priorities around, or actually when doing the schedule, suggest that you delay the maintenance by a day or so because it's not going to put the machine at risk, but it's also then going to satisfy a high priority production job. Now, of course, the counter argument to that is if the maintenance is to do with occupational health and safety or product quality, then it has to take priority over any production, because the scheduling environment and our own sense of what's right means that we have to put safety first. Then we have to follow it up by quality, and then we have to follow it up by delivery. So real maintenance management is impossible without the concept of condition-based preventative maintenance. If we don't monitor the conditions of our machines, as well as having normal service intervals, we then don't really capture the whole picture. Some of those conditions could actually be the quality of the product that we're producing, nothing to do with the machine itself. We'd also suggest that realistic planning is impossible without considering maintenance and production as a single schedule. If I'm doing my maintenance schedule in one space and I'm doing my production schedule in another space, then I'm always going to have a conflict. I'm never going to have an appropriate balance. I'm not going to be in a position to make capable to promise commitments, customer commitments, etc. Because, we were going to do a production run day after tomorrow, but we've realised the machine is down because it's got maintenance happening. Or what's worse is what happens if you do, by some chance, have a machinery breakdown. What's the impact of that going to be to the schedule? Can I run a what-if schedule question to the system on the basis if this machine is now down for maintenance for 2 hours, what is the schedule impact going to be? How do I then rebalance that schedule? And how do I maintain my customer commitments? If I can't rebalance that schedule and I can't make all the customer commitments, then how do I reprioritize those, and how do I get that message to the customer so that we're proactive in telling them that we're going to be late, we've had a breakdown, but we will be able to cover by such and such a date. Again, if you're working in two separate environments, you're not going to have that collaboration between maintenance and production. And that's going to lead to an overall lack of efficiency of the business itself. So what we have here is the holistic view of the Epicor ERP environment. Now, maintenance fits down in the service management area of the application. So this is to do with field service for customer assets, contract management, maintenance management, and mobile field service, which covers both internal and external assets. But that then works with the product data management, because yes, product data is about our finished goods, our sub-assemblies, it's about our components, but it's also about spare part items, product life cycle of that. It's about the maintenance operations, that sort of thing. It's revision control for components if appropriate. But that then feeds up into supply chain. And it's the same supply chain environment for spare parts and procurement of third-party services as it is for raw materials, components, and the procurement of subcontract services. It's a singular environment. So is finance. So the finance team doesn't have to learn a different way of working with a different system when it's spending materials money versus spare parts money. The reporting environment's the same, feeds into the same general ledger. So does planning. So if I'm doing materials requirement planning and resource management, I'm doing that for the production environment and the maintenance environment simultaneously, because the two of them are intrinsically linked. Like, if I'm doing finite capacity scheduling with capability-based matrices, then I need to be able to do that for the maintenance environment as well as the production environment, because they are just one shop floor environment. So production management, the whole concept around quality assurance and advanced quality management. Shop floor data execution, where I'm doing connects into PLCs. Do I want to do SPC, SQC data collection from machines to tell me how the product's going, but also give me an indication and therefore provide predictors on how the machine is performing. If the quality of the product starts to drift, if the performance of the machine starts to drift during creation of that product, then we need to know about that so we can engage maintenance at an appropriate time. Project management allows us to look at the holistic approach to the capital equipment itself. So from the feasibility study and justification of the CapEx, through the execution of that CapEx, the commissioning of the machines, and then year-on-year budget control for maintenance, repair, and overhead spend on that machine, all the way through to final decommissioning and disposal of the equipment. So a full financial life history of an individual asset. Planned maintenance, unplanned maintenance, upgrades, refurbishments, everything else, all planned, all understood. Human capital, in our context, allows us to explore the skills matrix of the appropriate resources, the people that are actually going to execute the maintenance. Do they have the skills? Have they been certified? Have they been safety inducted onto that piece of equipment so that all the checks, balances, and normal regulations have been signed off and are current? Underpinning everything within the environment is performance management. So I can look at reporting on my maintenance spend, my maintenance efficiencies, but I could do that in concert with how was my production efficiencies, what was my scheduling efficiencies, and how am I looking at my spend. So it's not a separate BI environment, it's just part of the whole. From a governance, risk and compliance, again, same rules can apply. The business architecture is the same, so the user interface is the same in maintenance as it is in production, as it is in product management, as it is in supply chain. It's one holistic environment. Right? The whole architecture allows us to do, is it SaaS, is it hosted, is it on-prem? You know, the mobility of devices to take maintenance protocols out to the shop floor with us. The whole global business management structures of multi-company, multi-currency. Give me a look at my global spare parts because I'm running, hopefully, similar machines in similar plants in similar countries. And what is my overall stocking of spare parts consumptions and so on. That's what we think is appropriate. We think it's appropriate that production and maintenance are the left and the right hand. I won't say which one's which, but they are part of the same whole process. So let's just go and have a look at how we address that. So if I look at equipment in the first instance, so what can I find out from equipment? Is this considered a fixed asset? We can have equipment that is considered a fixed asset or not because it could be equipment on loan from a supplier. So it's not our asset, but it is actually a piece of equipment which we need to maintain under terms and conditions from the people we've got it on loan from. Is it a resource? So is it something that is part of the scheduling environment? Or is it a piece of equipment that doesn't in itself get scheduled? I'll show you what I mean by that in a minute. Things like equipment status. Is it in service and active or is it offline? Who made it? Brand. What's the serial number? The model number. Now, when I'm looking at the labor interface, am I measuring this on the number of operating hours or would I measure this on the quantity of production that gets put through, or would I do a meter value? Or do I just not interface to that at all and I just pull straight from the meters? When did it go in service? When is it coming out of warranty? What's my normal daily usage of that? So I normally use this machine about 14 hours a day. So if I'm talking about a maintenance timing for a maintenance plan that says, well, I want this to be every 6 months or 1,400 operating hours, I can calculate when that is. Now, I can self-nominate that or I can calculate that off historical usage. Do I have a maintenance job that is a standard protocol for fixing this if it breaks? Where is this equipment currently? Does it have a parent? Is it part of a capital project? In which phase are we at in that capital project? We can also nominate who are the spare parts suppliers and the service suppliers. If it was a piece of equipment that a calibration, we could look for the inspection plan and the specifications and when that last calibration date actually took place. So maintenance management, looking at calibration, looking at feeding quality, and feeding all that information back. In this case, we'll have a look at the equipment and say, well, there are actually 3 pieces of equipment that are part of this. And if I wanted to then drill in and say, okay, give me a look at that child component, it's not a resource because it's the whole CNC machine, it's the whole mill that gets scheduled, not the tool changer. The tool changer is only part of the equipment. So you see that breakout between the equipment and the resource. This has a recurring preventative maintenance job that's done after 10,000 eaches. So the meter value can be different for the parent asset as the child. I could look at any maintenance logs that I had, which maintenance jobs took place, how much did they cost me versus how much did I estimate, and does this have any children? In the Epicor environment, we maintain child-parent lineage, 10 plus, 11 plus. Your entire facility could be one great-great-great-great-great-great-great-grandparent. You don't need to have a limited number of layers to that particular element. So even the parent equipment itself has a periodic maintenance, which has a template job to it. And this is a recurring task happening every 60 days or every 2,000 eaches, and I want the job to be generated a minimum of 5 days before the event so I can be ready for that work. Okay. Now, if I look, I can also see a non-recurring task for approaching end of life, and this is saying that at 9 years or 18,000 components, I think I'm going to get towards the end of the life cycle, and I need to do a review of that equipment, and end of life should take it 10 years and 20,000 eaches. So I can have recurring preventative maintenance and lifing considerations for that same equipment. Now, that's the equipment. If I look at the resource group, this is the set of resources that is the horizontal mills. I have 3 of them. I have my 3-axis CNC, which is aligned to a piece of equipment. It's not aligned to a fixed asset. So whenever I'm using this resource in planning, I'm also referencing the equipment. I know where this equipment has warehouses and bins, if I need to put spare parts, and vague interests, I've got finite capacity at a certain level. Now, see, I have capabilities. This one's capable of simple machining, and simple and complex machining. That's what we call capabilities. Now, what we also have is, yes, the simple and complex machining and the resources that can satisfy that. But we also have resources that can satisfy general preventative maintenance. Who is an electrician? Or for that particular machine, who's certified to do particular repairs? So it's the same scheduling engine for production environments as it is for maintenance environments. So finite versus infinite, backward schedule, forward schedule, capability matrices. So the environment is the same, and that means that we get a situation where we can see everything coming up together. If I look at my resource scheduling board, these are the jobs that are going through for that particular machine within this date range. Now, if I look at my schedule, I can see that actually I've got a production job. Then if I open it up, I have a maintenance job that's occurring on the 20th. And I bring that machine back online, doing more work. And over here, In January, I have one maintenance job with 3 stages to it. So even in the maintenance environment, especially in the maintenance environment, I can have 3 steps to a particular process. Now, if I look at the detail of this, and say, here is my maintenance job, and I've got 3 steps to that. So if I go and have a look at my maintenance job tracker, it'll say that there are 3 operations that are going to take place. Now, operation 1 is to make safe. Operation 2 is the machine checks. And operation 3 is to make operational again. Now, you'll see that the first resource is electrical engineering. The last resource is electrical engineering. But the person doing the checks is just engineering general. So I can break the schedule out for maintenance to say, right, electrical engineering, you need to, at such and such a date, take this machine down and make it intrinsically safe, because that's your job. Once that's done, you can handball that machine across to the maintenance technicians who go in and do the engineering maintenance and the other maintenance that are happening. Once they've finished that, completed their tasks, done whatever checks that they wanted to do, you can go back in and make that machine operational again. When I said you can do checks, you can be looking at doing calibration checks, and that as part of the general process that you go through within your maintenance environment. Now, we said we look at product data management. We'll look at the materials. So if I'm looking at spare parts here, what I'm looking at is a list of materials that are required for the different steps. So I've got 20 litres of machine coolant that's required for the work. I've got some flat washers, some nuts, some other bits. I've got some materials here, a shaft that's purchased directly for this job and this job only, because we don't stock it. We want it bought directly. WD-40 may seem like a silly example, but the reason we buy it directly for a job is because it just seems to evaporate if we leave it around the place. Now, in Epicor, you can have these work structures with 0 quantities, so that allows you to then go through and highlight that if you needed a particular shaft or a particular set of bearings on a particular maintenance activity, that it would have those predefined for you, and you just tell them how many you actually need. So you have the structure of the components within the equipment set, within the equipment hierarchy, and the approved operations with the approved resources to do the work. This feeds off and provides the buyers. Now, if the buyer is the same buyer for materials, depending on the size of your organization and everything else, or whether you've got one buyer for everyone or different buyers, sort by part number and say, right, well, there's my can of WD-40 that needs to be purchased. And that can of WD-40 needs to be purchased exactly for this particular job. So, production schedules, preventative maintenance profiles, predictive maintenance, creating planned maintenance activities that have authorized operations with defined staff against the skills matrix, authorized materials, whether they're stored, whether they're one-offs, whether they're on the fly, whether they're bought directly, feeding through into procurement, feeding through there and into finance. The whole system comes together to provide a holistic environment that keeps you running smooth and fast. So it's considering the whole environment, not just maintenance. Again, coming back to our scheduling board and saying this is the ultimate view of how I want to see production and maintenance working together. I have a maintenance activity here. I have another one in January. Production can fit around that. Now, we were talking about the whole concept of prioritization of work. Now, if I look at those particular tasks, I wanted to look at that particular maintenance job. I could look at the priority of that work. Is that work normal work? Is it high? Is it immediate? How does it fit into the schedule? Is the schedule locked, or is the schedule dynamic depending on demands and everything else? Has this been released for work yet, or is this still not yet released for work? If I wanted to release that for work, yep, it's in the schedule, fine, so I know that I can now start to action work against this. If I wanted to record the resolution, because I've actually done the work, it's recurring against the HAS. It was the 3-axis CNC. Actually, I went to the cooling tank and I did a flush and coolant change. Description. The coolant looked a bit on the dirty side, so I changed it out. Is the job closed? Yes. Do I want to record the meter? Well, if I said the meter was at 1010, thank you, that's closed, that job's done. Now this could be presented on a tablet to be executed immediately in front of the machine. You don't have to wait to come back to the office. There's that level of immediacy. And it's that simple from a reporting perspective to record that information. I'll just change that, save those changes. So coming back, given the time we have, this is our man standing in front of the machine. He's gone through and just reported that he's changed out the coolant in that machine because it looked a bit dirty and he felt like it needed to be. We were talking about the concept of departmental focus, that finance looks after fixed assets and that's a focus for them, and that's good. Production looks after their resources and plans their resources out to optimize their efficiencies, and that's good. Maintenance looks after the equipment because that's their job, and without that, I have diminished value of fixed asset and I have diminished production capabilities. But there are overlaps, there are touch points. It's not that the equipment stands in isolation from the production facility, far, far from it. The equipment is the production facility. It's just how I choose to represent it from a scheduling perspective and execute it from a maintenance perspective. So while I may have a departmental focus, I also have a company focus. I look at effective product design. I look at maintenance of the assets that produce that product. I monitor the quality of the product through production. I monitor my production efficiencies. We're dialoguing with each other, but essentially the primary focus of all of this is customer satisfaction. Delivery in full, on time, at the lowest cost and the best quality, in line with expectations that are set. It's just not as easy to do that if you have a maintenance environment that stands in isolation from your production environment. The benefits of having it all together. We think because you can get feedback from production into maintenance, and that you can time and interleave maintenance with production at an appropriate time and everything else, that you'll actually get reduced maintenance costs and downtime. You'll choose to take the machines down at otherwise unproductive times anyway. So really your downtime, as far as a lack of availability, is lower. Organised efforts to reduce waste, because if I don't have drift on my product, I'm going to improve my waste. If I don't break down because I've done the appropriate level of maintenance, I'm going to reduce my downtime. If the machines aren't down, the machines are up. If they're up, I'm going to get better capacity. And the whole supply chain management, whether it's the ability to turn components to finished goods and deliver to customers more quickly because my plant is operating in a smooth and efficient manner, or whether it's a case that I don't need to educate buyers and receivers and finance people on two different systems to execute my maintenance and my production environments, because it's just one. Because I don't have to potentially interface multiple systems together, because it's just one. The velocity and the smoothness with which I can execute my supply chain has to be improved. So for those who don't know us all that well, Epicor at a glance. We're 20,000 plus customers, nearly 4,000 employees. We operate in 150 countries, about 32 or 34 different languages, and we run at about $1 billion a year in revenue. Our focus is for customers 20 through to 2,500 employees. The mid-market, the manufacturer, distributor even, that has a certain volume of equipment, number of facilities, probably operates in one or more countries, etc., etc. Epicor, from an international context, is well represented across the world. Being in 150 countries and 30 plus languages, with the appropriate country-specific functionality, the compliance to various tax laws and everything else, with major offices in all the right places. One of the things that we think is most appropriate about Epicor is the flexibility to adapt best practice. We come into implementations with a certain level of experience and best practice templates, which we can then adapt, and the functionality will adapt to the individual business flows and requirements of each individual customer. We invest heavily in continuous technology innovation. That's why we're in the cloud. That's why we're on-prem. It's the one system across all. That's why mobility to us is just another part of the application. Deep BI capabilities to allow you to analyze the data. We're a manufacturing-focused solutions provider. We have a long history of experience in major manufacturing environments and can bring certain levels of domain expertise and vertical knowledge. We are understandably customer focused and provide high levels of customer service and support. We believe that's the only way to be successful, as most people do. So at this point, I'd like to throw the floor open to questions. We'll attempt to answer the questions. If you think of a question after the call, please lodge that and we'll come back to you. Okay. Like I said, if there's any other questions at a later stage, please get in contact with us and we'll revert back to you. But other than that, Clara, if you want to terminate the session, I'm happy with that. Thank you very much for your attendance.